Hello. Today we're going to talk about linear systems of inequalities. First, I'd like to review a little bit. Graphing linear inequalities. Remember, graph the line. Is the line solid or dotted? If it's solid, it's going to have an equal sign on the bottom. So it's less than or equal to or greater than or equal to. If it's dotted, it'll just be a plain smaller, less than, or greater than. After you graph the line, pick a point that's not on the line. Pick a point off to the side and plug it into the equation. If it works, shade that side. If it doesn't work, shade the other side. Okay, this is going to be real important in today's assignment because we're going to do basically this twice. So here's an example. If we're graphing this system of equations, we're going to start by graphing a line. So we'll start with the top one, plus 3. It means go up 1, 2, 3 spots. There's your y-intercept. Then find your slope. In this case, their slope is 1, so 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So on and so forth. Then, before I connect the dots, make sure you come in and take a look at this sign. Is that sign a dotted line or a solid line? Remember, if there's no bar beneath it, then it's a dotted line. If there's an equal bar beneath, then it's a solid line. So, this case, it's a dotted line. So graph that line just like that. Then we're going to pick a point that's not on the line. My favorite is 0, 0. Put in the point 0, 0, 0 for the x, 0 for the y, and say, does this work? 0 plus 3 is 3 bigger than 0? Or is 0 smaller than 3? Well, yes, it is. That means this point that we put here is on the right side. However, normally we just start shading like crazy. I'm going to say let's just, especially use a pencil on this, shade just a little bit on that side. And I'll show you why in a little bit. Okay, the next line. So we have a minus 1, so go down 1. And then our slope is down 2 over 1. So down 2, forward 1. Down 2, forward 1. Down 2, forward 1. Then again, look at our sign. If there's an equal bar, it's a solid line. If not, it's a dotted. In this case, it's again a dotted line. That means every point on this line won't actually satisfy the equation. So we're going to leave it dotted so we know that that's the boundary line. Okay, then let's pick another point. I can still use 0, 0. It's my favorite. 0, 0 is not in the line. And let's plug that into the equation. Is 0 bigger than minus 2 times 0 minus 1? Well, minus 2 times 0 is 0 minus 1, and that just leaves to a minus 1. So is 0 bigger than minus 1? Well, yes, I would say so. So that means this point is also on the point that gets shaded. Now, I'm just going to shade just a little bit for now. Now, I want you guys to notice how this breaks up our graph into 4 sections. We have 1, 2, 3, 4 sections that these 2 lines kind of cut it into. Now, we can see how 1 has no shading whatsoever. There's no shading at all. Section 2 is only shaded once by the blue. So that means every point to the right of that will satisfy the blue equation, but not necessarily the red equation. I'm going to skip down to 4. 4 is just like 2. This one, everything on this side will satisfy in the red equation, but not the blue equation. And it's actually number 3 that is satisfied with both our red equation and our blue equation. That is the answer. So what we'll want to do is we will want to shade this part of our graph. This is every point in here is the answer to both of our systems. And then what we can do is we can come back with our eraser and erase just that little bit, a spot, because that does not satisfy the equations. This does not satisfy the equations. Only that section 3 satisfies our equations. Good luck. Hope this helps.